In the notes section, let me upload this for y'all, will be a PowerPoint called the Flowchart Cookbook. One thing the Flowchart Cookbook is designed to do is to make the exam really easy. Because if I show you a picture of something like this without the words and I ask you what it is, you can just tab up and down to the Flowchart Cookbook until you find it and write down if statement. So remember the Flowchart Cookbook. Remember where to find it. As soon as it saves. Alright, if you want to read along, it's in the notes, Unit 1 section. So an if statement, we've talked about the logic for an if statement. The easiest logical structure in computer programming. If, do something. If it's not true, just fall through. Don't do anything. Just like the way we code it. We have an if and then a colon, we write some code. If else. Recall that there is no else block. If I give you code and ask you to write a flowchart from it, some people, they see the word else and they think that there ought to be a symbol on the flowchart. Reasonable assumption. It's just not the way it was designed. Not that flowcharting actually predates programming languages. So if you feel like it, you can take that word false or no and just rewrite it to the word else. Otherwise, just know that if you have an if statement that's got two branches, it's an if else. So same way, if colon tabbed code, else colon some other tabbed code. And then the elif statement, I believe we've talked about that. It just means else if. It's a way you can chain a whole bunch of if statements together. If grade greater than equal to 90, print you made an A. Elif grade greater than or equal to 80, print you made a B. Else, the final else, is just you didn't make an A or a B. That kind of thing.
How do you chain more of those?
Let's look. Very good question.
What's the file name that you uploaded that to?
Ought to be called, unless I put it in the wrong place, which is very plausible. Did I put it in the wrong class? Why, yes, I did. How useful. I'll tell you the file name, and if you could find it. Alrighty. Ooh. Gotta make a week 4. So in week 4, there's a flowchart cookbooks PowerPoint. Although I ought to modify it slightly with examples from code or pseudocode in it. So I'll upload a modified version just as soon as we do this. So here we go. Here's our if statement. Code-wise, you didn't ask about if statements. I'm just going to make examples for each one. Come on, guys. If x is equal to 0, colon, print by more x. That's that one. Let's do the if else. If eggs greater than 0, colon, print, let's eat eggs. Else, colon, print, Let's eat toast. So those are the first two. And then here we go with elif. And to be honest, I don't recall if we did elif. So if it's looking kind of alien.
You mentioned it briefly.
You mentioned it? Okay.
We didn't actually go into it.
So this is for something like this. If grade is greater than or equal to 90, I'm going to show you the wrong way to write this. Don't type this in. I mean, well, it'd be okay to make a change, but this is going to be the wrong way. Print A if grade is greater than or equal to 80, colon, print B if grade is greater than or equal to 70, print C. Like I said, this is the wrong way. Else, and this is a really harsh class, you don't make an A, B, or C, you make an F. At least that's the way your mean teacher, excuse me, your parents see things. Okay, so here we go. There is something drastically wrong with the logic of this code. Anybody see it? Yeah, it's not that there's too many ifs.
Else if
If it's
because
greater
it just,
than 90, it's going to be greater than 80 and 70.
Exactly. If the grade is greater than 90, you're going to make an A, B, and C.
right.
If you make an 80, you're going to make a B and a C. So what we want is a way to make these exclusive. Only that one triggers. Only that, or only that one triggers, or only that one triggers. Now there's other ways you could fix this. You could start it if grade less than 70, print F. If grade, oh, that still wouldn't work. Less than 80, no, that wouldn't work. You could put a range. If grade greater than or equal to 90, or let's change this one. If grade greater than or equal to 90, 80, and grade is less than 90. You know, we could make some changes here, but it's going to make the code more complex. So we could do this. Don't type this because I'm going to erase it immediately. And grade less than 90. That would fix the problem. But then if the instructor decides that, nope, grades above 85 are A's, well, then there's more than one place to change it. So here is the solution, is to use else ifs. In pseudocode, you actually use the word else. And in most languages, you actually use the word else. Else space if. But in this one, you do that. Excuse me, in Python, you do that. So this says, if the grade is greater than 90, print an A. Else if the grade is greater than 80, print a B. Else if the grade is greater than 70, print a C. Else, print an F. And like I said, there's always more than one way to cook a goose in programming if you wanted to, and I wouldn't necessarily take the time to type this because it's extraordinarily inelegant. You could do this. If the grade is greater than 90, it's an A. Else, colon. If the grade, no, okay, come on. If the grade is greater than or equal to 80, print B. Else, colon. You see what I'm doing? If the grade is greater than or equal to 70, print a C.
Do they need to be nested like that?
Only if we wanted it to work without making them else ifs. But that's the idea. Else, the grade is an F. You know, so rather than making it to where you have to do all that nesting stuff, programmers added else ifs or elifs so that you don't have to do all that tabbing. So you don't have to arrange it like that. And for whatever reasons, the designer of Python made them elifs instead. You won't see elif in any other language, but you have the concept else if or elif. Unfortunately, in Python, if you typed else if, I believe it would give you a syntax error. Let's find out. I'm going to delete this stuff because that was, like I said, a bad example, but I'm going to change these to what other languages would expect just to see if it works. Alright, so I'm going to save this one as flowchart examples. Not that they really are flowcharts, but they're the code that's going to come over here and be pasted into the PowerPoint. All right, so it gave us the syntax. If you run it and it highlights the if like that and the if is next to the else, just remember you gotta change it to elif. So that's the third form that's shown in the flow chart. There's two ways you could flow chart it, though. Or, you know, really, I think I've already said this. It doesn't matter which way the lines go as long as the blocks are hooked up. So if you wanted to flow chart it like this, if you kind of say to yourself, I'm going to make every if statement, if I'm going to make every else statement go off to the left rather than the right, and then when you hit if else, you could follow that convention if you wanted to. You could make the final else go off to the right, or you can make them all, you know, kind of go to the left and else just drop straight down. Doesn't matter. Just pick which one fits your brain. While loops. We've talked about while loops. You have a condition. Yes, you do something. Now, does Lucid Chart make them say true or false rather than yes or no? I ought to go back and revise.
Lucid Chart does yes and no.
It does yes and no? Okay, good. So while whatever, do some code, but if statements join back together like this. While statements loop back up to themselves because they're going to continue to repeat until this condition is false. And if this condition is false to begin with, it falls straight through. So this could be like, while candy greater than 0, open candy, eat candy. While candy is greater than 0, open candy, eat candy. While candy is greater than 0, nope, I've eaten all my candy, fall through. But if you got into this situation with no candy to begin with, while candy is greater than 0, it's going to fall through just like an if statement. And we know how to code this. All the stuff over here is in a tab. So let's code this. While candy is greater than 0, candy equals candy minus 1. Or if I felt like it, I could rewrite that as candy minus equals 1. And then that'd be enough. Like that. That's our while loop. The same syntax is used for for loops. You just put for in there rather than while. And hardcore flowcharters, Jedi level, might say that you can leave the word if out entirely and just put a greater than 0, you know. I don't agree with that. I think that there's no harm in sticking the word if in there. Similarly, you could say candy greater than 0 and not put the word while in there. It would be implied by the arrows underneath whether it was a while or an if. I disagree, because a for statement and a while statement look too similar, you know, in their syntax. So for x in 1, 2, 3, 4, this is going to print out those numbers. Print x. That's using a for with a list, or you can use a for with a range. For x in range, if I want to duplicate that range, I would want to start at 4. I would want to stop before we reach 5, and I would want to go up by 1 each time. So those two things do the exact same sequence of numbers. If you want to leave off this final comma 1, it's assumed by default. So what is that for? That's so that you could change it from going up by 1 to going up by tens or hundreds or whatever. If you were going to write this as a while loop, it would take more code. You would have to initialize x first, and then you would have to increment x each time. So expressed as a while loop, it would look like this. X is equal to 1, while X is less than or equal to 4, or you could say less than 5 if you want to make it look exactly like this loop here. Print X, X plus equals 1, or X equals X plus 1, however you want to write it. So this took 4 lines of code, whereas this took 2. If you think this is easier to understand, feel free to implement them as while loops. But if you're going to be iterating through a predefined sequence of numbers, generally for loops are preferred just because the syntax is more concise. And you'll see this syntax or something similar to it in just about every language you hit. And whenever I'm up here typing examples, I always forget the final step, the incrementing. And I don't have to worry about that if I'm using a for loop. All right, the while true with break. We haven't used this yet. So I'm probably not going to put this on the exam. Although if you just step through the flowchart cookbook, you'd see it. But I'm going to introduce it now. Suppose we wanted to ask the program if they wanted to play the game again. You know, we've written a guessing game, but you only had one shot through it. Once you guessed it, the game was over. You could do this. While true, colon. Print. Let's play a game. That phrase has gotten much more sinister since those movies. Alright. And then some stuff happens. Print. That was fun. And then we would want to ask the user if they wish to repeat. Input. Play again. Y/N. Oh, I forgot to store that input. I'm going to call that PA for play again. If PA is equal to no, then break. I'm going to put a comment here that's absolutely not necessary. So the way this works is while true essentially throws it into an infinite loop. Why? Because normally while gives you a condition, and when this condition becomes false, it falls out of the loop. Well, true can never become false, so it never falls out of the loop. However, break says, no, I don't care. And it forces it to go to the line after the loop anyways. Just breaks you out of this fence. And it works with for statements as well as while statements.
Why does the capital PA work on this one?
I am sorry, pardon me.
Why does inputting the capital letters
You
work
have
on
PA
this one?
capitalized in an if statement. You want to know if that's going to throw it off.
That would throw it off dramatically. They both need to be lowercase. Thank you for keeping me honest. Here we go. Kind of bugs people that you're asking yes and no, and then you're checking to see if it's no rather than yes. Well, it's because this is the break condition. That's when you want to stop. If you wanted to rewrite that so it didn't have a break statement, you would do it like this. You would have to initialize PA equal to yes, and then you would say while PA is equal to yes. I'm going to cheat and copy those 3 lines. And that's enough. So arguably that's simpler logic. The only difference is you have to set things up beforehand. What do I mean by that? If A didn't equal Y to begin with, you got to do that before you have to declare your variable, You have to have a variable before you can do a while on it.
How does it know to play again? Like, how does it know to restart?
The user types in a Y or an N, and then we,
No, I'm saying, how does that input, like, make it start again?
because it's a while loop, as long as they've typed in a Y, it will keep repeating. Just
So
like,
go all the way back to the top?
well, it's going to go to here again.
No, I mean, like, so where would you put this in a code? Like, would you put it at the very end?
She's talking about like if you're doing a guessing game
Yeah.
code.
Yeah, our
Where would
guessing.
you put the while statement in relation to the rest of the program code?
Right, right. So it would go up at the top above the guessing game. You're right. So you would wind up doing while, play again equals yes, and then your entire guessing game would be tabbed over one. If you happen to have your guessing game handy, which I don't know if I do, let's go make that modification. Okay, I have one called guess.py. I'm going to open it up. So I would need to do this. PA, or I could actually spell out the whole word if I wasn't lazy. Play again equals yes, and then while play again is equal to yes. Then I better tab all of this stuff over. I'm going to not tab these things over. Yeah, I guess I better tab that one over too. But I could change this input statement to be my check, you know. Right now that's just waiting for them to hit enter. Play again is equal to input. Do you want to play again? Y/N, like that. And then our final print could be, okay, we're done. That makes sense? You too? Okay. So then if I run it, let's prove it works. Rather than just take it on faith. I hope I haven't broken that program in the meantime. Guess the number 1 to 5. Okay, this is going to be hard. 3. Guess is too high. 2. I won. Do you wish to play again? Yeah. 3, 2, 1. You win. Tries is equal to 3. Game over. I wish you weren't hiding behind my toolbar down there. Do you wish to play again? No. Okay, we're done. So I think I'm going to avoid using break too often in this class. In the past, I've almost always done the while something is or while true, and then write the code and then use the if statement to break out of it like that. This is kind of a more traditional programming style. If you wanted to flowchart a while with a break, notice that there's no false condition on while. See? Because true never becomes false, right? So instead, you have an if statement, and if that if statement's true, you have a break, and it comes down here. So you can tell that that's just a little bit more convoluted, because if you compared it to that while statement, yeah, definitely a little bit more convoluted. Functions. I know we've done this at least once. You put your function call in a process box, but it's called a predefined process. It's got vertical bars on the side of it. And then you define your function not with a start, but with the function name. And if you feel like putting DEF in front of it, that's totally cool. So functions start with the function name, they have some code, and then they have a return statement. Then the code that calls them The main body of the code, the unindented code, has some stuff. It invokes a function. Now, when we were doing this in our in class, you know, we colored coded this so that like that was yellow and that was yellow, just to make it easy to see. All right, so that's our flowchart cookbook. Hope that made sense. I wonder why this says shapes and their purpose on that one. Okay, I will modify this with a sample code. I guess we're going to need a sample of the functions as well. So let's go down here and write a very, very simple function. def cube me. And it takes one argument. So we're going to define one parameter variable named x. So passed in an x, we're going to say y is equal to x times x times x, and then we're going to return y. So let's ask them for the number. We're going to have to convert it to an int. That's a lot of work, so I'm just going to shorten that to, you know, n is equal to 100. Result is equal to cube me x, and then let's print the result. Like that. So this is the function. If you're not returning a value, if it's just a return statement with no value, you can skip it entirely. But if you are returning a value, which we are because we want to store it here so we can print it out, you do have to use the return statement. And what did we say that functions are good for? Why would you ever even want to bother using them? Anybody recall? Our primary goal in using functions is to avoid doing what? Yeah, repeating code over and over and over. Because, yeah, in this case, it's kind of pointless, right? Because we just could have cubed result right there. But what if you used cube me 17,000 times in your code? Well, in this case, that still wouldn't help you much because it's just one line of code. But what if it was 20 lines of code? What if it was a very complex calculation? You would not want to repeat those 20 lines of code 17,000 times in your program. So, you use functions to avoid repeating code. What if the cube me not only took 20 statements to do, but you made an error in those, and you had cut and pasted that code, you know, 17,000 times in your program. Then if you had to change the formula, you'd have to change it everywhere. Whereas if it's in a function, you just change it once. You can fix that function. If there's something wrong with the function, you zero in on the single block of code that has it. Yes, sir.
What's the point of using saying n equals 100? Like if you don't ever call it. Like,
That was stupid. What is wrong with this? That should have been an n. Thank you. Yeah. My mistake. When we ran it, it would have broken. Good spotting.
Well, to reuse the X from earlier.
Right, I used the x, and that x would not have worked down here. It would have used x from up there. More commonly, if I was doing this, I probably would have said n is equal to 100, n is equal to cube me n, you know, and then print n, rather than store it in a different variable. But if I did that, I would no longer have the original value, and maybe I need it. So I show storing it in a different value. All right, we're going to change this. Midterm is next Wednesday, which is not July 3, it's July 5. Everybody have a safe July 5. No blowing fingers off. No driving while inebriated. No driving while anybody else is inebriated, which is hard to do. Okay. So if I hand you code that looks like this, start, input x, y is equal to x cubed, print y. What is that an example of? Yeah, that's pseudocode. That's not programming code. If we were going to rewrite this as honest-to-goodness Python, would we need that start and stop? No, we would leave that out. So the Python code would look like this. X is equal to input, and we may as well give them a message. Enter X. And then how do we cube Y? Well, there's so many ways. Or how do we cube X? We could do X times X times X. Is there another way? We've seen it to the power of. Like that. And then print Y. Or you might want to tell them X cubed is Y. But let's take that out. There we go. That'd be a fairly well-behaved program because they would know that they were supposed to enter X, and then we would tell them that X cubed is Y. Even more awesome would be if we actually displayed the value of X so that it said 3 cubed is 27. And you could do that like that. Now that's a lot more than here, and as usual I've made a mistake. Anybody see the mistake? Yeah, I didn't change it to a float or an int. So X is equal to float X, or X is equal to int X. I like floats because you don't have to worry that the user is going to enter a partial number. Maybe they really want to know what the cube of 0.3 is. If they type in 0.3 and you try to convert it to an int, your program will stop running. Speaking of which, that's one of the 3 types of errors. We have syntax errors. We have logic, also known as semantic errors. And then we have runtime errors. Which of those 3 types of errors would it be if the user typed in 3.3 but we tried to convert it to an integer, which has to be a whole number? Is that a syntax error? No, a syntax error causes the program to not even compile. You can't even get any output. A logic error is when the program runs, but it gives you the wrong answer. Crashing is not the wrong answer. Well, I guess it's a pretty wrong answer. But so a syntax error is like if you forget the colon, typos and stuff. A logic error is, runs but gives wrong answer. You tell it it's 90 degrees outside and it tells you that you better wear a parka. You're supposed to be calculating the cube of a number, but it only prints the square. It wants you to calculate the sum. Then you enter a series of numbers and it tells you that the sum of that is 0 every time. So a runtime error is when the program crashes, when the program stops running. It doesn't know what to do. It gets into a bad state from which it could not recover. I'm going to say that that's a crash. Examples of crashes could be it tries to open a file, but that file does not exist. There are ways you can handle that, right? You'd be really annoyed if Word crashed every time you tried to open a file and you typed in a file name and it didn't exist.
Or if you defined a variable as an integer and someone input like a float.
Exactly. Right. It's going to crash if you ask them to enter an integer, but they enter a float. If you divide by 0, that causes a runtime error. If you are writing to a disk and then somebody ejects that disk, then that's a runtime error. And when you learn more advanced programming techniques, you find out how to stop runtime errors from crashing your program. You don't want it to crash just because they ejected the disk. You don't want it to crash because they typed in a 0. There's a couple ways you could fix that divide by 0 error. One would be just to check. If, divisor is equal to 0, then print a message. Else go ahead and continue. And maybe you need to loop until they type a non-zero number. Or there are statements that will actually catch runtime error conditions. Those runtime error conditions are usually called exceptions. They're an exceptional state. And so programming languages have constructs designed to catch specific exceptions. In Python, it's just the except statement. I'm not going to show you that. Yeah. You don't have to remember this. But I believe it's like this. You say x is equal to 3 divided by y, and then you put except colon, and I'm never going to ask this to you again until you get to scripting. If you put print could not divide by 0. That stops it from crashing at this statement. It gets the error, but instead of stopping and displaying an error message on the screen and then, you can't do anything else, it actually prints an error message. And in that case, you'd probably want to do some kind of loop so that they could get a chance to get a new version of Y. That'd be the kind thing to do. Exception handling runtime errors. In Python, you use the except keyword. Alright, if you have these, 10.0 versus 10.0 versus 10, which one is an int, which one is a float, and which one is a string? So, what is that one? That's a string. What is that one? And this one's an int. Is this one an int because it's a whole number? Looks like a whole number? No, it's still got that decimal point, so the computer treats it like a float. The computer doesn't take the time to go, oh, that was a 0, so instead I'm going to treat it like an int. If it sees the period there, it gets treated no matter what as a float. All right, I don't remember even saying this. If I did, great. How many bits are in a byte? Some of y'all know anyways, even if I didn't say it. There are 8 bits in a byte. So, bitwise, you can go up from 0000, 0000 up to 11111111. And if we had to calculate what these numbers were, that's a 1 plus a 2 plus a 4 plus an 8 and a 16 and a 32 and a 64 and a 128. So that's actually equal to 255. 8 bits will store numbers of up to 255. The only data type anymore that people even sometimes use as 8 bits are characters. Why? Because there's only a certain number of letters, There's capital A through Z, there's lowercase a through Z, and there's all the numbers and all the punctuation. Those will actually usually fit in 7 bits. So that's why ASCII in the old days, in the 60s, was defined as a 7-bit character set, or an 8-bit character set if it's called extended ASCII. And extended ASCII is when it's got those funky things where you can type, Alt 254 and get a block, and Alt 253. What I'm doing, I think we've already done this, is you hold the Alt key, you type in some numbers on the numeric keypad, and then lift up, and it gives you some extra things that aren't on the keyboard. But there's a problem with only having 255 available characters, which is if you're going to squeeze French and Russian and kanji and who knows how many different flavors of Chinese and whatever, you're going to very, very, very rapidly exceed 255 characters. So there are 16-bit character sets now, multi-byte character sets. That's called Unicode. Unicode has, all sorts of languages defined in it. I'd be surprised if it didn't have Elvish and Klingon, characters defined in it. Okay, so PEMDAS. Let's list some things, not braces. if I asked you to rearrange these from the ones that get done first in an equation, the highest priority ones, the highest precedence, to the ones that get done last in an equation. So order of precedence, PEMDAS. Which of these get done first? Parentheses. Right, so that's the first one. What gets done next? The E, exponents. What gets done third? MD. Now, although it shows M and D, it doesn't mean multiplication gets done before division. It just means it goes left to right and whichever it finds first, whether it's division or multiplication. They are actually equal priority, right? And then, so that's the third. And as far as PEMDAS is concerned, floor division. What's the difference between division and floor division?
The remainder?
Yeah, floor division loses the remainder, rounds it down to an int. And modulus means the remainder. Okay, so that means that addition and subtraction are the fourth. Addition and subtraction, again, just happen left to right. It's not like addition has a higher priority than subtraction. They have the same. All right, so if I ask something like this, a question like this, write Python code that asks for your favorite color and then prints out the message, your favorite color is, followed by the color. You ought to be able to do that. Now, I'm not being super specific. I didn't tell you how to ask for the favorite color. I didn't tell you the variable name. You get to pick those. But I'm sure you can do that. Similarly, if I say write Python code that asks for X and then prints X times 10, you ought to be able to do that. Whether you use int or float, I didn't specify. I gave you a variable name this time. I didn't tell you what message to use inside the input statement. I didn't tell you exactly what the output. That means that I'm going to be, really generous. But I would prefer you to actually, I don't want you to do this, X is equal to input. Then the user doesn't know what they're supposed to type. So that really ought to be something like enter X. That kind of thing. What is it called if you add two strings together rather than two numbers? If I have A is equal to George spelled with it. Yeah, why can't I type today? Plus a space plus Washington. What will A equal after that's done? A will equal George Washington. And what's that called? We might call it appending in our head, but that's not the programming term. That's called concatenation. Concatenation. And you'd probably pick that right out if you saw the word, If I ask you to summon it out of memory, it's slightly harder. But if it's multiple choice, it's not so hard. All right, I need to rewrite this question because it's always a little bit difficult. But if I write something like this, X is equal to Y times 2. And I ask, what are the operators? Tell you what, I'm going to change this a little bit. Print Y times 2. I want you to tell me, there are no keywords in this one yet. So, tell me the variable, operators, there may be more than one. In this case, there's not. The function name. So, what are the variable or variables in that statement? There's one variable. There's also a named constant, which is 2. What are the operators? There's only one. It's multiplication. What is the function involved? Print. And lastly, what is the operands? Operands are the things that the operator acts on. So there are 2 operands in this case. Let's come up with a slightly more difficult example. If A is equal to 10, or if A is less than 10, print the integer value of C. So again, we care about variables, operators, operands, functions, and keywords. So what variables are there here? A and C are variables. What are any operators we see? We actually only see one operator. What is an operator? It's a symbol that does some kind of logic or math. Less than. What are the operands? A and 10, because those are the things that the operator works on. What function or functions are there? Print and int. Right. I'm going to get rid of that word int, because that is actually a keyword if it showed up there. And the keyword, what keyword is there? If. And if we coded this in Python, it would probably color the keyword, orange or something, and, our functions would be a different color. Okay, so y'all recognize those.
What exactly is an operand?
If you have A plus B, B is the operator, and A and B are the operands. So the operands are the values that operators work on. May as well write that. Operands are the values that operators work on.
So I guess in that example, if is the keyword because everything falls underneath it, and then print is no longer a keyword, it becomes a function, or it's basically just using a function of print.
It's not a conditional based on where they are. Functions are anything followed by parentheses.
Gotcha.
So they invoke some code. Somewhere in the Python guts, they have some code that's associated with the print statement. Keywords are the ones without the parentheses.
So like define for a function would be.
Yep. So we've seen several keywords at this point. Let's put that. Functions have parentheses. Keywords don't. How many keywords have we seen? Well, I don't know, but let's write some of them. If, while, def, did I hear another one? Else, and then elif. They are the verbs of the language. They actually define the language, and then the functions, are blocks of code that are written elsewhere. And we've seen some functions and we've written arrows. I'm not going to ask you for a list of keywords, but if you see some code, you ought to be able to pick them out. We've probably seen more than that. I think we've used and or. Have we used and or yet?
Not much.
Not yet much. Okay.
The for loop.
Then we need to hit that again. All right. Kind of tired of reviewing. We may hit a few more things on Wednesday review. Consider that all reviewing. Maybe we hit a little bit of material. So we're going to talk about logical operators now. So far, we've seen the math operators, plus, minus, multiply, divide, like that. And then we've seen comparison operators. Less than, greater than, less than or equal, greater than or equal. Oh, and equal, equal. Now we're going to hit some new ones. Logical operators. The words and or. Some languages use symbols for them. Some languages, 2 ampersands for and 2 vertical bars, the shift backslash for or. I'm going to take the words for out. Why do I say that? Because you're likely going to go on and do programming in other languages besides Python, and the vast majority of them use symbols rather than words. But I'm not going to ask you that. That's just to tuck away in your brain. So, the way they work is they chain. You can write more complex if statements. If money, I always put parentheses on my if statements because they are required in other languages, not this one. If money is greater than 0 and hunger is greater than 0, print. Let's go out to eat. So and means both sides have to be true. Both operators. Really, this condition here is an operator. Excuse me, an operand, but I'm not going to. Okay. So, and means both sides are true. Or we could do this. If money is equal to 0, or less than 0, we could be in debt. Less than or equal to 0, or hunger is equal to 0, print, nah, let's stay home. You see the difference. And means both of these have to be true, or means if either one of these is true. So and is kind of both, or is either. If you treat ands and ors, if you treat trues and falses as zeros and ones, they kind of look like this. If you wrote the expression A and B, and then you wrote the result, there's 4 different possibilities. And let's do them with trues and falses first. They both could be false. One could be false and the other could be true. One could be true and the other could be false, and then they both could be true. So, if those are false, then the result is false. Neither A nor B are true, so the result has to be false. How about if one thing is false but the other is true?
False.
It's still a false, because and means both have to be true. That kind of gives the game away for this one. Is that going to be a false or a true? False. And then lastly, the only time an and is true is when they're both true. This is what's called a truth table. There are also truth tables for or statements. A or B, and the result. You have, again, 4 possibilities. 2 variables with 2 states. 2 times 2 is 4. So false and false, if both sides are false, absolutely the result is going to be false. What about false or true? That's true. And true or false is true, and true is true. Something to kind of notice is that there's only one true case with an and. There's only one false case with an or. So if you see a whole bunch of trues in a truth table, you know it's an or. If you see a whole bunch of falses in a truth table, you know it's an and. I'm not going to do it, but you could cut and paste those and replace all the falses with zeros and all the trues with ones. and you'd get a binary truth table. You know what? I am going to do that for a specific reason. This is something you don't have to type. But I cut and pasted those, and I'm going to change all the falses to zeros. Wish I could do a search and replace, but that would not work.
Why not?
Because it would change all the capital T's and F's that I had up there. So, plus I don't think Notepad has a replace all. There is a reason I'm doing this. That's a truth table, a binary truth table for and this is a binary truth table for false.
By the way, it does have a replace all.
Oh, okay. I should have used it then. No, again, I probably would have regretted it. Okay. There we go. What I want you to notice here is if this was math and you replace this with times, then it kind of works, right? 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. So, if you ever go and take a logic class, and in some universities there are logic classes, then they may represent ands with multiplication. Similarly, if you have pluses here, a 0 plus a 0 is a 0. A 0 plus a 1 is a 1. A 1 plus a 0 is a 1. And this is kind of the funny one, but if you're dealing in binary, you only have two choices. So if you're dealing in logic, you only have true or false. So 1 plus a 1 is equal to a 1. So, ands can be thought of as multiply, ors can be thought of as addition if you're taking a logic class. I think I'm going to delete all that. All right, let's go see where we are in our textbook. We were talking about functions. For example, you can write a function that draws a square. Let's do that and then use it to make a more complicated thing. We did this in the past with something that would lift the pen, draw a shape, and then put the pen back down. I don't think we need to make it that complicated for this example. But let's make a new file, call it T-square for turtle squares. Save it somewhere, but not in your Python, not in that guts Python directory. Make sure you save it into your own work directory instead. I'm going to call it T-squares because we're going to be drawing squares. What library do we import for turtle stuff? Import turtle. When I want to create a new turtle, I do something like, well, I give it a name, Leo or T or something like that. T is equal to what? I want to create the turtle so I can draw with it. Pardon?
Lowercase turtle dot uppercase.
Yep, lowercase turtle dot uppercase turtle parentheses.
Yeah, that still seems overly complicated. Why can't it just be a lowercase turtle and then parentheses?
Well, I will show you a syntax that actually works, that lets you get away with something like that. You could do this. From turtle, import turtle. And then you could do T is equal to turtle. I'm going to comment that out. What this is saying is from that library, I want you to import this specific command. And then you don't have to preface it with the library name first. Works. Maybe I ought to do it that way so that we don't have to type turtle dot, but there aren't that many places in the code where we use that keyword. As to why it's an uppercase T rather than a lowercase t, I guess that's just a distinct, nope, I can't come up with a reason. They made that decision, not me. Okay, so we've got a turtle now. Let's define a function that draws a square. Define, let's make it simple, square, and it needs a parameter which is going to be both the width and the height. I'll just call it x. If it was a rectangle, it would need two variables, you know. Okay, so what we're going to do is we need to draw four sides. We could do that with a loop, or we could just do forward, turn right, forward, turn right, forward, turn right. You know, we'd have to have 8 lines of code if we were not going to use a loop. I suggest we use a loop then because we can kind of shorten it. So for, now I wish I hadn't called it x. For in range 4. Now we've talked about it, if you only use a single number, where does a range start from? Where does it start counting?
0.
Starts counting at 0 and it goes up to, but not including 4, so that's 0, 1, 2, 3. So the highest number in the range, it does not get to. So if you're trying to figure out, you know, how many numbers are in it, you start at 0 and you go up. Or you can specify the first value. I could have put a 0 comma, that would be good syntax. If I put 0 comma 4 comma 1, if I spelled out absolutely everything to be pedantic, that would also work. Okay, so we want to go forward, t dot forward, x pixels, why x? Because that's the number that the user specified. And then we want to turn either left or right. I like turning left for some reason, so it goes up rather than down on the first turn. 90 degrees. Why 90? 360 divided by the number of sides. If it was going to be a triangle, it'd be 120 degrees, because 360 divided by 3 sides, 360 divided by 3 is 120. Okay, now that's enough. We could put a return statement. We could leave the return statement off. Why do I say that? Because we're not passing a value back, so it's not strictly necessary. But if I wanted you to flowchart it, you would need to put that return word down there at the bottom of the flowchart no matter what. So I'm probably going to use a return statement most of the time unless I'm absolutely trying to squeeze as much stuff as one time. Okay, let's test it out. Let's draw a square that's 200 pixels. All right, we have our square. Now let's loop, drawing a square and then turning a little bit. You know, over and over and over. At one time we did a whole bunch of circles to kind of make a flower shape. We're going to do the same thing with squares instead. I'm going to delete that line for now. So let's figure out how many squares we're going to want. Let's say it's going to be 8. In that case, the angle is going to be equal to 360 divided by the number of squares we want to do. And then we can use another while loop. Or a for loop. I'm almost making this too complex. Maybe I should have. Okay, anyways. For, I hate to use x, counter in range number. Because if we're going to draw 8 squares, then we want to count it from 0 to 7. Now let's call the square function. We didn't pick a size, we didn't pre-code it in a variable, so I'm just going to say 200 again. But now I want to turn, either to the left or to the right. I think it'd be kind of interesting. What am I doing? T dot left by the angle. All right. This ought to draw 8 squares on the screen if I have not made any syntax errors. Yeah, your question about capital letters, why is that capitalized but the rest of these commands are not? I guess just to trick us. I'm sure there's a more fundamental reason than that. So it draws a square. Maybe I should have added a speed 0 command. Alright, once you get yours working, pick some other numbers. Try 16, or 32, or 64. Or if you do those shapes, it'll kind of be geometrically perfect shapes. If you choose something that's not a multiple of 2, or a 4, or an 8, if it's not going to be one of those square numbers, then it'll look different. So like type 45 or 15 or something. And then I'm going to wander around and make sure everybody's doing good. But first I want to try that out myself. I'm going to change the number equal to 15. I want to see how many squares that draws. We can figure it out. 3. Of course it's going to draw 15. I just told it to do that. Kind of cool. A high-tech spirograph, if any of y'all played with spirographs as a kid. Nowadays kids play with iPads and Android tablets. Rather than boring. Okay.
Fidget spinners.
Pardon me?
I said don't forget fidget spinners.
Yeah. Alrighty. Pause the recording. Let's make one more little hacky change to it and then we'll take a break. I'm going to max my speed out, so I'm going to put t.speed 0 at the very top. And instead of square, I'm going to do instead of a square of 200, I'm deleting that 200 and I'm making an angle. That didn't do what I wanted. Let's try it again. Let's change it for counter. Let's change that to counter. So I changed that 200 to a counter. Why? Because I want the squares to get bigger as they go along. Kind of like a nautilus shell. Okay. It worked, but it's kind of small. Let's change that counter to something multiplied. So counter times, yeah. So counter times, I don't know. I'm going to try 10 first. Yeah. I should have increased the number. You're right. That would have been the best way to do it. I'm going to change num to 360, and then I'm going to change that counter back down to 10. Or just, yeah. I'm going to remove the multiply on the counter. I don't know what I was expecting, but this is kind of cool. Anyways, hopefully you see the point. By putting the function, that code in a function here, we didn't have to cut and paste these 3 lines over and over and over. Well, I guess it would have only been in one place. We have encapsulated this stuff so that it's done just with a single word. And if we wanted to call square multiple times in our program in 20 different places, we could do that. We could just copy that, you know, call square, rather than have to put these statements. Now, is 3 statements that much? No, but we've seen functions that are more complicated than that, like the one that lifted the pin, and then it did, you know, set X, and then it did set Y, and then it put the pin back down, you know, and then it, you know, in the meantime it drew a shape. So that was more lines of code. That was our draw circle code that we used to draw smiley faces, etc. Hey, neat. It's art. I'm going to print it out. Hang it on my wall. All right, guys. Let's take a break. Be back here about 1:35. Bathroom, drink, whatever.
Can you put the pseudo code back up, please? Or the square stuff?
Yeah. I realized as I hit it that that was a bad idea.
Thank you.
Along with the string concatenation operator, multiply also works on strings, which is a little bit silly. I know I've shown this to you before, but if I do A is equal to 80 times hello, and then I print A, it's going to print A 80 times in a row. Have I ever used that? Not really, but you could use it to make something 80 spaces wide or draw a line of 80 dashes or something. So some functions require arguments, some do not. We could have written that square program so that it always just assumed a size, but we didn't. It took an argument. You call the argument that you're passing in the argument, but when you're coding it, like we did here, you call the parameters, the variables that accept those arguments, parameters. So this function has 2 parameters and you feed it 2 arguments. I don't ask on an exam to pick exactly which of those is which because it's too easy to confuse them. You'll say this function takes 2 arguments, or I'm going to pass in this parameter. So some functions do return values, some do not. If they do return a function, they are called a if they do return a value, they're called a fruitful function. They bear fruit. This function that we drew here, the square function, does not need to return a value. Why? What would it return? I can't think of anything it ought to return. So it's not a fruitful function. Does that mean it's a fruitless function? They actually call that a void function. So let's write down some definitions. Function is a block of code that is attached to a function name. Functions can be written to accept arguments or not. We've seen 2 different examples of the input function. You could do either x is equal to input, that's no arguments, or you could put something in here. That means that they actually coded it in order to do that. Usually if you write a function and you specify that it takes arguments, if you don't pass any in, it crashes. So if I go back to my code example here, and I try to draw a square but I don't specify a size, like that, that's going to crash it. Not going to work. I need to change that even more. But anyways, what it says is square is missing 1 required positional argument. It's going kind of positional, I don't know, but required an argument. An argument to fill in the x parameter, and we did not give it one. So when you write a function, if you specify a parameter, you better pass something in. the number of arguments must match the number of parameters defined for that function. There are built-in functions. Print, input, range. Range has got a parentheses after it. There are some built-in math functions. I'm going to pop open the shell just so I can play with those. I'll pop open a new shell. So POW of 3 to the power of 4. That's a function. The absolute value of 10. The absolute value of negative 10. I am sure there are all sorts of other ones like sine. Nope. When I typed sine, it didn't make it. I probably have to import a math library to use sine. Let's see if we can get an interesting list of built-in functions. Built-in Python functions. All. Meh. Sum is one of them. LEN for the length of a string is one of them. Bin for binary. If you pass in a number, it converts it to a binary string. So if you pass in 8, it'll return 1000. Okay, most of these I don't see us using too much, but sum and length are very important, so we will hit those. Okay, there are a lot of them. Float and int. Okay, let's tack on a few more to our list. Sum, where you can say I want the sum of 1, 2, and 3. The length of a string. The integer value of something. The float value of something. Why did I start putting parentheses after them? I don't know, but I better do the same. So a range of 4 input, give me number, print, hello, okay. I'm going to go back to the shell, play with a few more of those. So if name is equal to Jeff, then the length of name is 4. If we have a list of numbers, let's see, what's Jenny's phone number? 8675309, and we want the sum of that. The sum of L is whatever those numbers are added up, 38. Length is going to become a lot more important as we start talking about lists. Actually, I'm not sure length is going to get a lot more important, but sum is nice. If you ask the user to input a series of test scores and you put them all in a list, then with a single function call, you can get the sum. Otherwise, you'd have to write a loop that would step through the list, pulling each number in, adding them, or whatever. It'd be nice if there was an average function as well. I can't say that I think there is. Average of L. No. Well, especially when prefaced. Give me a break.
Could you define an average function and then put the pre-built sum function as part of that?
You could. You could do this. I'm going to define average. It's going to accept a list, and it returns the sum of the list divided by the length of the list. And I was wrong when I said we're not going to use length that much, because length works on both lists as well as strings. A string is essentially a list of characters. And now, if I want the average of that list, so 8675309, the average is 5.4. That's kind of a neat function. I think I'll just copy that and paste it into our notes. Now we talked about strings, searching strings for a specific character or value, like the $sign and a price, and then slicing. We need to hit those again. And since we've talked about them before, we hit a chapter on them, then when we actually get to that chapter, it's going to be pretty easy. So say you do this. A is equal to George. Then what is A at position 0? It's the first letter. Right. A at position 4, well, we just have to count. 0, 1, 2, 3, 4. So it's a lowercase g. What is the length of that string? The length of A is, I believe, 6. 1, 2, 3, 4, 5, 6. You can specify 2 numbers. You specify the starting position, and then you specify one before the ending position. So if I do this, A, 0, and 2, then that gives me GO, or just G, GE. Why? Because we start at 0 and we go up 2, but not including 2. So that's 0, 1, we don't get to the 2, so we get GE. The way I remember it is I just take the difference between those two. So if I did this, A is equal to 1:4. 4 minus 1 is 3, so I know I'm going to get 3 characters starting at position 1. If you feel like it, you can leave off the first number if it's 0. So I didn't have to do A is 0, 2. I could have just done this. A, 2. Looks a little bit weird. It's not like typing at 0 took a lot of time, you know. So why do I care about that? I don't know. But it's really important if you need to, well, no, anyways. If you do this, A is equal to 2, that goes all the way to the end of the list. If you leave off the number after the colon, it assumes that you mean the end of the list. Why? Because otherwise you'd have to calculate the length of the list and use that. So this means start at character 2 and go all the way to the end of the list. So that's 0, 1, 2, 3. Okay, so it would be org. That's different than not having a colon entirely. If you leave off the colon entirely, it just gets you 1 character. If you leave out the number before the colon, it assumes that it is starting, the slice starts at 0. If you leave out the number after the colon, it assumes that the slice ends at the end of the string. What if you leave out both of them? If you did this, x is equal to a, what do you think that's going to do? Where's it going to start? It's going to start at the beginning of the list. Where's it going to end? The end. So it just makes a copy of it. Copy the entire string. I can't think of too many times when you do that, because if this was a string, you could just do that, right? It would copy the string into X. But if you're dealing with lists, it's actually not a bad idea sometimes, because you might have a list of scores, but then you might want to be able to change values in that list but preserve your original data. That would copy the scores into a new variable while leaving A alone. Again, we'll get to that with lists. So our built-in functions, I really can't think of too many more that we're going to be hitting. I forgot ABS. absolute value. We know what those mean. I'm not going to put comments in them all. So functions can return values, in which case you have to use the return word followed by the value. Here they give an example of implementing this function. That is the compound interest function, meaning this is actually worth coding in, I think. P stands for principal, R is the annual interest rate, N is the number of times a year, and then T is the number of years. And you can use that to calculate, I had $1,000 at 2% interest. It gets compounded 12 times a year. And I want to find out after 5 years how much I would have. Let's write a function that'll do that. I don't want to stick that onto the turtle code though, so I'm going to do one more file for today. File, new file. I'm going to call this one interest. Save as interest.py. And I don't want to steal their code. I just want to figure out myself. I do it myself. Based on the formula. So we could ask the user all these values. For now, I'm just going to hard code them. I'm going to be doing what I should have done all along. Put my name, the date, calculates interest. They're mixing capitals and lowercase letters. I think I'm going to use either all lowercase or all caps. A is equal to. Now, when the equation is written like this, I think I mentioned this. Books forget the multiplication symbol. What do I mean by forget? They just skip them. We can't skip them. So it's going to be A is equal to P times, parentheses, 1 plus R over N. Now I can't just say to the power of N times T. I'll show you why. This would be not correct. What is wrong with that compared to the equation?
Because then it would do, just N as the exponent, put parentheses there.
Right, since exponents have a higher priority than multiplication, it would do all that first, and then, oh, now I'm going to multiply the whole thing by that. So we need to tack on parentheses here for it to be correct. Okay, obviously that's not going to work because we haven't assigned any of these things values. So I'm going to say I have $10,000 in a bank. That would be nice. Then I'm going to do an interest rate of 2%. Anymore, that's also nice. N is equal to the number of times per year, 12 times a year, and then T is the number of years. And then let's just print out A. Oh boy. I seem to have done something wrong because I don't believe that that could possibly be accurate.
Well, you
Oh, I
calculate 12
forgot.
times a year,
That's
so
200% interest. I wish. Okay, we're going to change it to 2% interest. That's better. After 5 years, I would have 11,000 in that account. We could put this in a function. This code right here. Now Python, unlike some languages, require your functions to be defined before you use them. So why don't we cut that You know what? I don't really feel like doing all that. We're just going to leave it at a theoretical, yeah, you could code that in a function. Why do I not want to bother? Because then, let's just go on from there. If you want to see how to code it in a function, you could check the text. So variables and parameters are local. What does that mean? If we do this, if I define a function called cube that takes an x, and then it says y is equal to x to the power of 3, and then it returns y, and then I do this, print the cube value of 100, which ought to be 1,000,000, I think. Anyways, if later on I try to print out x and I try to print out y, I can't. Like this is a little fence. These things are defined inside that fence. These are defined inside the function, so they're not available outside.
So that's what it means by being local.
Right. These are local to the function. Y is local to the function. Parameters are also local to the function, but at least you're passing something in. So if I'd stored this 100 somewhere, I could print it out. But I can't print out x because x is local to the function. So is y. What if you want a value to be used between multiple functions? That's,
So if it
in
returns
some
y-
languages, they're called global variables.
Can't you type like non-local.y or something like that?
I don't know of that keyword. You can type global y. Are you saying that because you know it works?
No.
Okay, because people know things I don't. Non-local Python. Okay, Python introduced a non-local keyword. You were right, there is one. I don't see them using it. What am I missing? That was great. Yeah, apparently so. However, it doesn't mean create that variable and make it available everywhere. We can test that and try it. I'm going to type non-local here because the suggestion was to use a non-local keyword. I know that print x is not going to work, so I'm going to comment that one out, but I'm curious if that makes y. What do I have to do? Non-local y, and then y is equal to? Let's give this a shot. All right. If I defined y beforehand, if I said y is equal to 0, and then I wrote my function, let's see if that works. Okay, I'm not going to spend any more time learning that until I know what it does. There are such things as global variables. A global variable is one that's defined outside of the function. It would look a lot like what I just did. So pretend that none of this was on the screen and I just opened a brand new file. In fact, that t is equal to, you know, turtle stuff, lowercase turtle dot uppercase, and then I define functions like square, t dot forward 100, whatever. I'm not going to actually code it, you know. And then down here, I can call square. This is called a global variable. This variable is accessible to all the functions that are defined underneath it. Now, usually when you use a global variable, you have to indicate that it's a global variable. I would have to say, and you don't have to type this because I'm not writing complete programs. I would have to say, oh, by the way, I'm going to be using a variable that's defined outside of the function, and it's okay if you change it. The reason why we got away with not having to use that variable, that keyword, we haven't seen that before, is because calls like t.forward don't actually change the variable. Yeah, it's just using the same turtle. So we don't have to do that. Just kind of tuck away for future reference that there is a such thing as a global variable. A global variable is one that's defined above all the functions. It's not considered the world's greatest programming technique. I'll leave it at that. Thank you for mentioning that. I need to learn what non-local really does. I kind of see there, but I wasn't getting it quite right. Alrighty, so our glossary. What is an argument? It's the value you pass into a function when you call it. What is the body? They're giving a dumb definition here. The body is the code inside the function. They're calling it something goofy. They say the second part of a compound statement. Meh. I like my definition. Anyways, they're saying that a compound statement features a header and then a body. I don't know if I care that much about it, but that could also include a for x in range whatever, and then some body underneath it. They would call that a compound statement in this text. They would even call an if statement a compound statement. I don't feel like doing that. The body of the code is the stuff that's indented under the header. If could be a header of a block of code. A function definition could be a header of a block of code. That's usually what I mean when I say body. The body of the function. Docstring, we didn't talk about that. Flow of execution is the order in which statements are executed. What does that mean? Well, when I run this code here, it starts here. It does all this stuff. Keeps running top down, keeps doing, and then does it do that?
No.
It skips that because it's a function definition. So the flow of execution would jump down here, and then it would try to print the cube value, so flow of execution bops back up here. Then it runs those two statements, and then it comes back. It would print y out, which would still be an error. Neither of these work because x and y are local to the cube function. A global variable is one that is defined outside of the functions, before the functions. Some languages do not care about the order in which functions are defined. Python is not one of those languages. If you do this, I'm going to go back to notes so I'm not messing up my beautiful code. If you do this, define B, call A, and then you do define A, print hello, and then lastly down here you call B. This will not work. This is broken code. Why? Well, this line's going to work. Conceivably. It could jump up here and run that. But then when it calls A, it doesn't know what that is. It hasn't been defined yet. So Python function definitions are actually important in the order in which they happen. That is not true of some languages. Of the most famous languages, C and C++, you have to forward define your functions. And they give you a way to do that if you want to define a function, but you don't actually want to put the body of the code up there. Then there's something called a prototype where you give the header of the function, but you don't put the body. Java, on the other hand, doesn't care what order you define your functions. Just remember that in Python you do, and in some languages you don't. I'll put a comment here. The order in which functions are defined is important in this language. Code above would not work because A is not defined before B. So let's do something. Let's write a function called a even if something doesn't have parameters, you have to put the parentheses there. Just like when you use the input statement, even if you didn't have anything to print out, you have to put the parentheses after the input. Okay. So this is going to print hello. Then we're going to write another one, B, that prints apple. And then we're going to write one. Why did I put that inside parentheses? That was bad. That calls A and then B. Shouldn't have done this on the fly. I should have had it prepared. I'm going to make a change to this. I'm adding a call to A inside my B function. What would this print out without actually running it? We can think it through.
Hello, Apple, hello.
Yeah, it's going to print hello, apple, hello. Why? Because the flow of execution, the very first line that it actually runs, is that one. Why do I say that? It's the first unindented line of code that's not a function definition. So flow of execution starts here. It bops up here, and it calls A, which prints hello. This returns, even though there's no return statement, if it's not returning a value, you don't have to put the return statement. The reason I do is so that the flowchart, when you write a flowchart from it, so it would bop back down to here because it's done with A, and it's going to call B. What does B do? B prints apple as its first thing. But then it calls, it calls A, which jumps it back up here. Prints hello. Then it jumps out of that, and it's done with that one. So it hits that invisible return. Now it's done with calling B, so it hits that invisible return, and the whole program is done. So if you have a lot of functions and they're calling each other, you just have to kind of be able to work your way. Make sure that things happen in the order in which you expect. So a function is a named sequence of statements. It's a block of code with a name that performs some useful operation. Well, I hope it's useful. Functions may or may not take parameters and may or may not produce a result. I don't like that produce. Return a result. Hopefully it's producing something, even if it's just dots on a screen. I'm just going to copy that entire thing. So function is a named sequence, a block that perform a useful function. Functions may or may not take parameters and may or may not return a result. Arguments are the values that you pass to functions. Parameters are variables that accept arguments. A fruitful function is one that returns a value. If they don't return a value, I made a joke that they were fruitless, but the technical term for it is void. Some languages actually use that word to define a void function. This one does not. So fruitful function is one that returns a value. We keep writing a cube function. For example, our cube function returns a value. A void function is one that doesn't return a value or returns no value. Our draw square function didn't need to return a value. I skipped a word. This sentence, no verb. Our cube function returns a value. Okay. Y'all are a cool class. You write down the notes as I write them down. In some classes, most people don't do that. And I think that writing the notes burns them in. On the other hand, you know yourself, and you know that if some people type more slowly, so I understand that. Okay, exercises. Write a void, non-fruitful function to draw a square. Use it in a program. To draw the image shown below, assume each side is 20 units. Now this is assuming something that they're not actually telling us. How are they achieving those gaps between the squares? Yeah, they're doing, yeah. Lift the pen, go forward 20 pixels, drop the pen. Write a function to draw this. Assume the innermost square is 20 units per side and each successive square is 20 units bigger. Now when we did something like this, I know we did it with a circle. It drew one circle and it drew another and it drew another and it drew another. They were all hooked up together at the bottom. If we called a square function over and over, it might start small and it would get bigger and bigger and bigger, but they would all be hooked up at a corner. So what would we need to do? We would need to lift our pen.
You have to move X and Y
You have to move off that.
The
equal
same
amount.
thing we do with the face.
Yeah, but you would have to move not only horizontally but vertically. You might, go back 20 pixels and then up 20 pixels. Turn your pen back down. Put your pen back down. Write a function that draws this. Draw poly. So this professor, the author of this one, doesn't like global functions, so they pass the name of the turtle into every function. That's okay. They would want to write they wanted to write a function that took a number of sides and then the length of the sides. We could do that. We could change our square function so that it was a generalized polygon function. So that's actually going to be our homework. I'm going to give you this code that we wrote here, our square function. Using this code as a start. Write a program, or write a function that accepts two arguments. A number of sides, 4 for a square, 3 for a triangle, whatever. And then a length of sides argument. So you could call it like this. Let's name our function. Let's give a name for it. The name of the function should be poly. Alright, this is really easy homework actually. But if you wanted to draw a square, you could do poly 400. If you wanted to do a hexagon, like that, and so on. Then use your function like this. Alright, I'd prefer if you actually, even though this is simple, if you actually waited until class was over before you coded it. We've done stuff like that. Now I've written functions that draw stars before, but I don't remember how to calculate the angle. And it has to be a non-even number, because like if it was a 6-pointed star, it's actually 2 interlocking triangles. But say you wanted to write code that would, draw a star with 5 or 7 or 9. You can't just do 360 divided by 5, because it instead would be a pentagon. Here they give us a hint that for 5 it's 144. Just a thought experiment. I'm sure there's an equation. I'm absolutely sure. I just don't remember it right off hands. All right. We're not going to actually do any of those other ones. Conditionals. Programs get interesting when we test conditions. We've actually been doing this all along and change the program behavior depending upon the outcome of the test. Ask the user for age. If the answer is 17, tell them they can't join the Army. A Boolean value is either true or false. It is named after the British mathematician George Boole. Boolean algebra is a math system in which there are only two possible values. 0, 1, true or false. And then you have rules for reasoning about combining those values, specifically and or. So we haven't actually talked too much about the Boole variable type, but you can have those. If you do this, age is equal to 17, and then you do too young is equal to age less than 18, then by the time that's done, too young will equal false. If you print it out, it will print out false. No, it'll print out true because 17 is less than 18. So, yeah, we don't even have, yeah, let's throw in a print statement. But we don't need an if in this case. Too young. That would print out true. Let's do another example. The temperature is equal to 67 degrees. At the standard pressure of 1 atmosphere, then the freezing point of water is 32 degrees and the boiling point of water is 212. So freezing is equal to the temperature less than 32. Boiling is equal to the temperature greater than 32. Nope, 212. And then if we print freezing and we print boiling, well, what is freezing equal to after this code runs? 67. Is 67 less than 32?
No.
No. So freezing is going to be false. It's definitely not freezing. Is it greater than 212? Again, no. So it's neither freezing nor boiling. We could make a third variable, called liquid or something, where we check to see if it was between those two values. These are what are known as flags in some texts. A flag is a true-false variable that, you use it to store a state. Why do you do that? Well, you can get the state, but the state might be more complex than just a less than or a greater than statement. Maybe it may be several things long. Like if you're going to ask the altitude of it, and you're going to ask the atmospheric pressure, that kind of stuff. In the calculation for whether something is freezing or boiling is more complex than just the temperature. I believe that water boils at a lower temperature up high, like at Mount Everest. Yeah. So if you're going to boil water at a height of 20,000 feet, it takes less heat. So all of these are what are known as Boolean variables. Store true-false values. Now normally I will not code this. Usually I will not do if or freezing is equal to temperature less than 32 and then if freezing. Maybe I will. If I'm going to use this variable over and over and over, or this condition over and over and over, then maybe I will. But usually I would just write if temperature is less than 32, print something or whatever. So you can use Boolean variables to drive if statements. Also while statements. Here's a more proper example. while keep running, colon. That's assuming we already have a keep running variable. We would have to define our keep running variable like that. So while keep running, play our game, parentheses, and then ask the user. X is equal to input, play again, y/n. If X is equal to no, then we set keep running equal to false. We could even simplify that into a Boolean expression like this. Keep running is equal to X. No, why am I putting two equal signs there? What's the difference between a single equal and a double equal?
A double equal makes a comparison.
Double equals for comparison. So if X is equal to no, yeah, then we want to keep running. I like putting that kind of thing in parentheses just because it makes it clear. But you don't have to. Okay, so this would play our game. It would ask them, do they want to play again? If they type yes, that should have been in quotes. If they type yes, then keep running is set to yes. And it keeps going. If they ever type in anything other than a capital Y, even if they type in, lowercase y or yes, the whole word, then it's going to bail. So if we were going to take more time on this, we might convert the input into uppercase, and we might just grab the first letter of it so that we could do that kind of comparison. But I would make this example. You can use Boolean variables to drive while statements. You wouldn't really use for statements because for statements iterate through a series. They either iterate through a range or a list. So we already have the concept of these clearly. We know what greater than and less than and greater than or equal or less than or equal to. We know what all that stuff means. Although these operations are probably familiar, the Python symbols are different from math symbols. A common error is to use a single equal rather than a double equal. Okay, we've established that. One more difference is that you can't use less than, greater than. If you want to do less than, greater than, you actually have to do not equal. So out of all of our comparison operators, you have double equals, less than, greater than, less than or equal to, greater than or equal to, and then you have not equals. So you cannot do this. Cannot use just because they say so. Not like some universal law.
Are those in the right order? The greater than or equal to?
Yeah, they are. If you tried to write that, it probably would not compile. We could prove that real fast. Good question. Some things I take for granted just because I've seen it for a long time. Let's try it out.
Didn't we just use those,
Okay. So let's find out if 10 is greater than or equal to 5. Syntax error. You have to put it in that order. And yeah, we were just using that. Logical operators. The logical operators are the ands and the ors. And we already went over what those are good for. If your name is equal to Joe and your age is greater than 18, age is greater than or equal to 21, print okay, Joe, you can go drink alcohol. Or buy alcohol. You can drink alcohol at any age, right? It's not illegal to consume it. That's a stupid one. Let's make it 18. Because I'm not a proponent of drinking. Don't get me fired for that. You can go vote. There we go. Now this is silly. Why is Joe the only person who can vote? I don't know, but we've written it like that. If we wrote it with an or statement, it would mean that anybody named Joe could vote, even if they weren't 18. So let's clarify this. Only people named Joe and who are 18 or greater can vote, according to that logic. Let's reword it. If name is equal to Joe, or their age is greater than or equal to 18, same thing. I don't know why I didn't just cut and paste. Okay, Joe, you can go vote. Well, what's wrong with that? They can vote even if their name is not Joe, so we shouldn't be printing okay, Joe. So anyone named Joe can vote. Anyone who is 18 or older can vote. If that's the logic, if Joe is a special name, then okay, that might be what you want. Not a particularly good example. If sick and tired, print stay home. That'd be kind of a bummer because even if you were sick, you'd have to go to work unless you were also tired. If sick or tired. Let's rewrite this logic a little bit. Print stay home. So or is used. Okay. How would you do this if you instead wanted to print stay home, go to work? If you wanted something that would check if sick and tired, and you wanted the result to be print go to work. Well, there's more than one way to do this. But we could do this. If sick is equal to false and tired is equal to false, print go to work. That's one way to do it. You could do this. If not sick and not tired, print go to work. So doing this, if sick is the same as if sick is equal to true. If you do this, if not sick, that's the same as if sick is equal to false. Now, there's nothing wrong with doing this rather than doing this. There's nothing wrong with doing this rather than doing that. So that is one more operator. Not is one more logical operator. When Colbert used to say the truthiness, not reverses the truthiness of it. If it was false, it becomes true. If it was true, it's evaluated as false. So if not age greater than or equal to 18, 80, then print you can't vote. Personally, I avoid not if I could rewrite it to be simpler. I'd rather say if age less than 18 rather than if not age greater than 18. But maybe sometimes it's easier to do. Like here, if not sick and not tired, go to work. That was a little bit simpler than writing it like that. I might still be tempted to do it that way though. Just because the more words you add to something, especially involving not, you know, the twists of logic involved to think about flipping the logic, it becomes a little more complicated. All right, we're getting near to the end of our journey today. Our truth tables, we talked about that already. In the AND truth table, both things have to be true before the result to be true. In an or truth table, if either side is true, it's true. And then the last truth table is for not. I didn't do that, but if you pass in a false, it becomes a true. If you pass in a true, it becomes a false. I don't think I'm going to talk about simplifying Boolean expressions in algebra. We did talk about if you say, no, that's not even where we're going to. Conditional execution. Usually this is how you do it. You use an if statement and an expression there, and that drives it so that conditionally that one will happen or that one will happen. We're whizzing through this chapter because we already know a lot of this stuff. The syntax for the if statement looks like this. We know this. If Boolean expression, which could also just be a bool variable, do something, else do something else. All right, so the second part of the homework is going to be this. Write code that asks the user for their age. If their age is, oh gosh, what is the age range for the Coast Guard? It's like 3 different states. If you're under a certain age, you're allowed to do it. If you ask your parents, okay, we're just going to make it up. Okay, if your age is 16 or 17, print, ask your parents permission. So this is the Coast Guard assignment. If the age is 18 up through 32, print, you can join. If the age is greater than 32, print, you can join only with prior military experience. So not terribly hard, right? You're just going to use some kind of if statement, some kind of logic, some kind of else's. However you want to word it is up to you. I'm not going to dictate what form of logic structures you use. All right, let's put that in a Word document. And we will be done for today. If you want to hang out and work on homework or ask